This is the outdoor circuit of a Gree Mini-Split air conditioner. It is a brand new PCB, but currently it is showing an E6 error. I will now power it up and check why the PCB is not functioning properly. We will identify the fault and fix it. So, as you can see, this is a completely fresh PCB. The customer who provided this PCB complained that about a week ago, they purchased 3 ACs, and out of the 3 PCBs, one is having an issue. We will now repair it and inform you about the issues we find in it. Now, I will start testing from the fuses. I have set the meter to continuity mode, and I will check the fuse. The main fuse is of 15 amps. Since I didn't notice any physical issue, I will now check all the components step by step. I have already checked this fuse, and it is perfectly fine. After this, there is another fuse installed here. You can see it is connected in series with these capacitors. So if we check anywhere along with these capacitors, you can see that we are getting the proper beep sound, indicating that this point is perfectly fine. Now if we test from the other point, it's also perfectly fine. This means that both fuses are completely okay. So first of all, I will power it up and check how this PCB is behaving. Initially, I will test it without the unit to see if the PCB turns on or not. After that, we will test it with the motor. But the complaint from the customer is that this PCB is showing an H6 error. Often, if the PCB is dead, it doesn't work at all. However, if the unit is running but still showing the E6 error, then we have to perform a complete test to identify where the fault is. So I have set up the entire system for testing. I have attached the wires with it to power it up. To check the signals, I have set the meter to DC voltage mode and connected the wires properly. Alright, let's start it and show you what's happening. I have now powered on the PCB, and as you can see, it has also started switching. Additionally, you will notice the lights flashing. Currently, 2 lights are flashing, one green and one red. If we check the signals, it is showing an output of 55.6 volts here. Ideally, it should have displayed slightly lower voltage, but still, let's test it with the unit and see what happens. As you can see, I have connected this PCB, but it's not the exact model for this unit. That's why I am doing the testing with some modifications. The final testing is always done inside the AC unit. We can check everything with the meter, but the final test to ensure it's working properly has to be done inside the AC unit itself to confirm it's functioning as expected. Here, you can see that we are using a UVW DC fan, and for this, we are using a fan from a Sharp unit. As for the compressor, we are using the original Gree compressor. I will now check everything thoroughly and show you the progress I have made so far. As you can see, I have turned it on, and right now it is showing a temperature of 16 degrees. You can also see that the blower is running, which is visible inside. After a short while, it will display the E6 error. Additionally, if we check the signals, they are showing up perfectly fine at the moment. Everything looks proper right now. Now, we will wait for a while, and then I will show you if it displays the E6 error. After that, we will start the repair process. As you can see, the E6 error is now displayed. I will remove the circuit again, and then explain to you how I checked it and performed the repair. Now I have removed the board, I will start the testing. There are a few possible causes for the E6 error. When the PCB is completely dead, it will show the E6 error. Additionally, if any component on the PCB is short-circuited, especially the IPM, IGBT, or the fan motor circuit, since it is a UVW DC motor, the PCB can become completely dead, causing the E6 error to appear. Oh, as you can see, everything is working fine. Since a communication error is occurring, I will now check the communication-related circuit. After that, we will continue checking step by step to identify the issue. Now, let me explain where the communication circuit is located. As you can see, this entire area is the communication circuit, and the voltages, both up and down, come from here. There's one optocoupler here that receives signals and another optocoupler that sends signals. These signals are sent directly to the microcontroller, enabling communication. Now let's talk about testing. I will test all the components while they remain on the PCB. After that, if I suspect any component, we will remove it and test it separately. So as you can see, I've set the multimeter to the ohms or kilo ohms setting, and our circuit is auto-detected. Now here we have a zener diode installed, and high voltages are entering from this side. The neutral is directly connected to this capacitor. So now we will check these components. So if the zener were short-circuited, it would repeatedly pull down the MCB or blow the fuse. But since that's not happening, it means the zener is fine. Now, I will check the resistance here. It shows a 13 kilo ohm resistance, and the voltage drop is 12.83, so this is fine. Let's check the next resistance. This one is also perfectly fine. Both of these resistances are connected in series and are working properly with no issues. Now here we have 3 more resistances. Let's check them. The first resistance is giving the correct value of 36 ohms. Next, we check the second resistance, and it's also showing 36 ohms. These 2 resistances are connected in parallel with the positive and negative terminals of the capacitor. However, when we check this third resistance, it's showing some issue. So, we will remove this resistance from the PCB and test it separately. Next, we will check the next resistance, which is a 13K ohm resistor. As you can see, this resistance is also perfectly fine and showing the correct value in the circuit. When a component shows the correct reading in the circuit, there is usually less reason for doubt. However, if it starts showing incorrect readings within the circuit, it becomes a bigger problem. Now, let's check all the diodes, as there are quite a few of them. Some are normal diodes, while others have specific functions. I'll switch the multimeter to diode mode and check each diode one by one. You should know the anode and cathode of the diode. There is also a marking on the circuit board to identify them. This point here is the cathode, and the other point is the anode. When we place the positive probe on the anode and the negative probe on the cathode, we should get a reading. As you can see, the value is absolutely correct. However, it is essential to check the diode's reverse polarity as well to ensure there is no leakage in the circuit. At this point, it is showing absolutely fine with no leakage. Next, we will check the next diode. Here, the cathode is at the top and the anode is at the bottom. First, we will check its correct polarity, and it is absolutely fine. Now let's check it in reverse polarity to see if there is any leakage or issue. As you can see, it is also showing perfectly fine. In this way, you can see that the cathode is at the front and the anode is at the back, and it is showing perfectly fine. Now let's check it in reverse polarity. In reverse polarity, it should block the current. Initially, it showed a reading for a moment and then stopped, which sometimes happens in the circuit. This is still considered normal, but to eliminate any doubt, it's better to remove it from the PCB and check it separately. As you can see, it is absolutely fine. However, since there is an issue with the PCB, we will still remove it and check it separately to be completely sure. As you can see, there are zener diodes here. Let's check them. This zener diode is working perfectly in both forward and reverse polarity. Similarly, you should check all the components one by one. For example, there is another diode ahead. We will also check it. To identify its anode and cathode, if there is no marking on the diode itself, you can refer to the marking on the PCB, which will help you determine the correct polarity. Similarly, we will check the other one as well. Now let's check its reverse polarity, and it is also showing perfectly fine. Zener diodes typically have a voltage rating of around 6.7 to 7 volts. Normal diodes typically have a forward voltage drop of around 0.4 to 0.7 volts, which helps identify if they are working correctly. At this point, everything here is absolutely fine. Now the next step is to check the 2 resistances. I'll switch the multimeter back to resistance mode. Let's check this resistance first. Its value is marked as 222, which means it should be 2.2K ohms. As you can see, it is showing the exact correct value, so it's absolutely fine. Now, let's check the next resistance, which should have a value of 470 kilo ohms. A slight variation in the value is acceptable. However, at the moment, it is not showing any value. So we will switch the probes to the other side, but it is still not showing any value. Next, we switch the multimeter to diode mode and check it. Here, we should check for continuity between the collector and emitter. Ideally, there should be no value shown between the collector and emitter. However, in this case, it is showing a value. On the other point, it appears to be working fine, but we are not getting the expected resistance value. Now let's check the next diode. We should get a reading on the diode because one side is the anode and the other is the cathode. As you can see, the value is correct on this side. Now let's check the other side. It also shows the correct value, so everything is fine. Now, the 2 resistances that are showing issues are R502 and another one. We will remove R502 from the PCB to check it separately. Apart from this, we will continue checking other components as needed. We will also remove and check resistance 136. Now let's perform another test, the capacitor test. We will test it by supplying DC voltage. The capacitor should block the DC current. If it works properly, it will not allow DC to pass through. For this, we will switch the multimeter to continuity mode and check for a sound. Now we will apply the probes to the capacitor's polarities. When the capacitor is supposed to block the DC, it will initially give a beep sound, and then the beep will stop suddenly. This means the capacitor is working correctly. However, if it continuously beeps or doesn't beep at all, then there is definitely a problem with the capacitor. In such cases, it is important to remove it and check it separately to confirm the issue. So when we change the polarity and check again, we hear the beep sound once and then it blocks, which means the capacitor is absolutely fine and there is no issue with it. Now, our main focus will be on the two resistances that showed issues. We will replace those resistors. Additionally, we will also replace the receiving optocoupler and check to ensure everything works correctly after these changes. Now that we've removed the capacitor, which was necessary to check the resistance, we can see that the resistance is showing the correct value in its position. This indicates that the issue was likely caused by the capacitor. As you can see, I have placed the meter here, and when I check the 100K resistance, it is showing the perfect value. The full 100K is correctly displayed, indicating that the resistance is fine. Now, let's change the polarity and check again, as sometimes a resistance might show correct on one side, but not on the other. We will also check the upper resistance once more. It is showing 36, so the position is correct. Now, let's figure out where the fault is. I will explain it to you. As you can see, the optocoupler that we removed is showing a high value, which indicates it is not functioning correctly. When we normally test it, there should be no value coming through on the emitter or collector, but it is not showing anything now. Since we can't be sure whether it is working properly or not, we will replace the optocoupler to resolve the issue. The main issue here is with the 474 resistance, which is not showing any value. I believe this might be a factory defect. I will replace it, and after that, the circuit should work perfectly. The main problem lies at this point because the voltage was showing high earlier, as I mentioned. Now, we will replace it and install the new one. I hope that after following this method, you will be able to repair your PCB in the same way. In addition to this, we will also replace the other optocoupler to ensure the circuit functions properly. Click on the left or right thumbnail to watch our next videos and subscribe. Thank you.